What if your interviewer asked, "So, can you walk me through how raw text turns into those magical vectors everyone keeps bragging about on LinkedIn?" What would you say? It's 2025, the US. Economy's still running on efficiency mode, phone companies are downsizing faster than your token limits, and engineers everywhere are learning to store knowledge smarter, not bigger. In this environment, organization isn't optional, it's survival by structure. Alright, let's break down the workflow. Now that we understand embeddings and vector databases, let's go through the workflow of transforming raw text into stored vectors that can be used for retrieval. Step 1. Splitting the document. Large documents such as books, reports, or long PDFs are first split into smaller chunks. This is necessary because language models perform better with smaller sections of text rather than large blocks. Step 2. Converting chunks into embeddings. Each chunk is then converted into a vector embedding, a numerical representation of its meaning. This is done using an embedding model, such as OpenAI's Embedder API, which processes the text and outputs its vector form. Step 3. Storing embeddings in the vector store. Once the embeddings are generated, they are stored in a vector database. For each chunk, both the original text and its corresponding vector are saved. This allows the system to retrieve the actual content along with its semantic representation when needed. Why this matters? At this stage, the entire dataset is organized inside the vector store. When a user submits a query, the system no longer needs to scan all documents. Instead, it retrieves only the chunks most relevant to the query, which speeds up search and improves accuracy. What's next? With the data now stored and indexed, the next step is learning how to query these embeddings to generate precise answers. This is where the stored data becomes actionable and useful for the language model.